guys, today I'm going to take a look at Azure Container Instances on Azure. Now this is a fairly straightforward offering on Azure. It basically gives you the ability to spin up one-off containers, or you can deploy them in groups if you want. But this is mostly intended for small-scale container deployments, and you can deploy these rather rapidly, either using the Azure portal, or you can use some YAML files that will create these containers in an Azure environment without the need to spin up any kind of infrastructure or deploy any other resources other than what you specify. And so it's a serverless billing model, and everything about it is really designed for ephemeral workloads that are easy to spin up and spin down without having to reserve a lot of capacity. So let's just go in and look at an example of this, and I'll show you kind of how it works in the portal. Then I'll show you an example on the command line just to show you how it works, and then you can see the results in action as well. So creating one of these in the portal is pretty straightforward. If you are looking at your home, you can go to create a resource and then just type in container instances on the marketplace and search for that, and then you'll get an option for it. Now, you click create here. It's going to take you through a wizard that doesn't expose all the options available to container instances, but it does give you an idea of a lot of the things you can do with these. So I'm going to use an existing resource group, but you can create a new one here. And I'm going to call this one Keen Demo. So I'm going to use Commander Keen and DOSBox for this demo. You can choose availability zones as are currently in preview, of course, and you can choose one of two SKUs. Now, the standard SKU, of course, is just the standard offering, and it uses hypervisor level isolation. Basically, it's done at the hypervisor level. So you might be sharing underlying hardware with other instances that are run by other users, but you get decent level isolation just using that. If you want complete isolation, use the confidential deployment right here, and that will give you much better isolation than the other one will. Now, the size and image are two things that you can choose here. I'm not going to use the built-in image here or container registry. I'm going to use another registry right here and use a public image. And I'm going to use blaze/DOS game. This is available on Docker Hub, so that's where it's going to get it from. And so for this, I don't need a big size. I can use 1 vCPU and 1.5 gigs of RAM. You can choose this right here. You can tune this. So if I want 1 gig of RAM, you could do that. And you can choose different kinds of GPUs available to you. So these are all NVIDIA GPUs that you can choose if you want to do GPU bound workloads, and it'll mount that into the container. And you can do things like AI if you wanted to use a GPU for this. But for this particular demo, I don't need any of that. I just need a CPU and a little bit of RAM, and it'll run this one just fine. Now, this one will allow you to run this on public and private endpoints. So if you want to install this in a private VNet and have it bound to the VNet, you can do that, or you can bind it to a public IP address and connect to it that way. If you put it on the VNet, you can put something in front of it like an Azure App Gateway or some other security appliance if you want to filter the traffic. So it's just an option if you want to do more security than what it offers out of the box, which is pretty much nothing. It depends on what you put in the container as to what is going to be the security demarcation here. So I'm going to call this one Keen Demo. And it's going to check that for the uniqueness of the name. You need to have that available for the uniqueness. And then the DNS namespace, it's going to say the tenant, and that's fine for mine. Now, the port, you'll want to expose the port for your container. Of course, mine's going to be on port 80. This is a web app, so I'm going to use that. And on this next one right here, you can set things like environment variables and startup commands that you can use to configure the container if you need that kind of thing. I don't for this particular one, so I'm not going to use anything on this, and I don't need any tags. So I'm going to click review and create, and this will pretty much create this instantaneous. It takes about a minute, and it's going to have to pull the container and start it. Most of that time is going to be pulling the container, which this is a fairly large container. It's not massive, but it's bigger than a trivial container. So I wanted to use this one just to give you an idea what you might expect from a more production-oriented application. Okay, that only took about 45 seconds to do. So I'm going to go to resource here, and I have a URL here that I can use to connect to this guy. I could also do it by the IP address that it's assigned to. And now this is a web app, so I can just use HTTP in the browser and load this guy up. And this might take a second to spin up the external endpoint for this container. Okay, there is the endpoint after it started everything up. Now I'm going to click on this, and this is going to launch no VNC. And if I type in password 1, you can see that I have DOSBox, and I'm going to install this game. And you can see that it's actually doing something. This is all running in a browser, so everything is running inside of the container and streaming the results back to this. Now, this particular demo should have sound, because I recently updated this particular game to use sound in addition to the streaming. So let's start a new game here. And I can play Commander Keen right here inside of a container, and it's pretty nice to do this. This is not using a lot of CPU, but it does demonstrate something that's more than a Hello World style application, because it's not trivial, but at the same time, it's also very fun to do. So using the portal is pretty straightforward. It's not hard to create these, and this is good for testing out containers and things like that. But if you wanted to get a more DevOps approach to this, or use some kind of automation, of course you're going to want to use ARM templates, or you're going to use the Azure CLI to do the deployments. I'm going to show you how to use the Azure CLIs using a YAML file that it will accept for deploying these guys. So the YAML file is pretty straightforward. It basically gives you the ability to configure everything about the container, just like you did in the portal, with more options exposed. So I'm going to use one of the more advanced options, which is using storage with a container. And this will allow me to have more permanent, persistent storage that I can use with the container, even though the container itself might be ephemeral. And that way, when I shut the container down and it gets deleted from container instances, whatever it changed will be around. And that is going to be fairly straightforward using Azure File Storage. So I've already created the storage account that I'm going to use for this guy. It's pretty straightforward right here. It's just a storage mount that I'm going to be using from file shares that I called ROM. So what I'm going to do with this is upload a ROM into my next demo, which is going to use RetroArch. So that'll be the game that I'm going to play inside of RetroArch. Now, RetroArch on a container is pretty straightforward, but I'm not so much interested in RetroArch as I am in deploying a container to container instances. So for this particular one, I'm going to be using a little bit more in terms of compute capacity, because it's a little bit more demanding in terms of what it needs to run this. So to run this, I'm going to basically use this YAML file. And this YAML file deploys the container, it deploys all of the resources that I need, and it will mount the storage that I need. So the YAML file looks like this. It's going to have the container that I need to create, which is going to be this one right here. I have one called Blaze/RetroArch out there on Docker Hub that is going to download it. Again, it's going to use port 80. I'm going to throw 4 CPUs at this and then 1.5 gigs of RAM. That's probably more than enough RAM, but 4 CPUs ought to be enough for this. Notice I have a mount path though. I'm going to mount the ROMs at this root right here called ROMs. And if I do that, anything I put into the file storage will show up in that folder inside of the container. Now I'm using a Linux host type. You can use Windows containers with these. It has an IP address of public, and it's going to be mapped to port 80, which of course is going to map back to the port 80 on the container itself. And down here is where I define the volumes. And I'm using Azure files for the volumes, and I'm calling it config for the, I'm going to call this particular share, I'm going to call it ROMs. That's what I've called it. And then the storage account name is RetroArch, and the storage account key is right there. Now, this particular one I have right here, I'm going to call it ROMs right here, and I'm going to call it ROMs down here. And that way everything is mapped correctly. Now I'm going to save this file, and I'm going to use the Azure CLI, but I'm going to do it inside of CloudShell, inside of the Azure portal. But you could use any instance of the Azure CLI wherever you might be running that from. It's just convenient to do it inside of CloudShell, which is pretty straightforward. So this will work with Bash or PowerShell. The Azure CLI works the same regardless of what operating system that you choose. So I'm going to upload that file right here. I'm going to upload that little YAML file. It's called test.yaml. Now the command to run this is pretty straightforward as well. So I have the command right here, and basically what I'm doing is I'm telling it which container I'm going to create a container using AZ container create, and container is the group for Azure Container Instances. Then create, I'm going to tell it which resource group, which is ACI-demo, and then the file, which I just uploaded called test.yaml. Now I can run this, and then it will basically run through the process of creating this using the Azure Resource Manager, but it's going to be doing it through the CLI. So I won't have a visual representation, but I'll just get some YAML output once this is done creating, which will take about a minute, maybe a minute and a half, because it's a little bit beefier of a container than the one that we just looked at. Now that one's finished. So let's pull this down just a little bit right here and go back to my resource group, which should have 2 container instances now. I have RetroArch right here. And this one is at this endpoint, so I should get the same kind of thing that I got before. And this one has the same VNC client installed, And if I connect to this, we'll see that I have RetroArch up and running here. I'm going to configure this and come back, and then I'll show you my mounted ROMs that I'm going to upload into the storage, and it'll show up inside of this. So I've configured this now, and to show you that there's nothing in here right now, I'm going to look at the ROMs folder where I was supposed to mount things, and there's nothing in there right now. But to rectify that, I'm just going to upload something through the Azure portal into that share. So ACI demo is where I have everything set up, and I have it set up in this storage account right here. And I'm going to go over here to file shares and then click on ROMs, and then I'm upload into this right here. So I'm going to browse to this file right here and upload it, and upload it. Now that that's uploaded, it should be in my ROMs folder here. So let's go back to the parent directory, then let's try to reload the ROM. And there it is right there. Now, if I click on the ROM, it's going to start loading that ROM. And I can see that I am now playing Mario Kart inside the context of Azure Container Instances by way of a ROM that I uploaded into my file share. So this is pretty straightforward. It's a fairly straightforward demo in the way of Commander Keen, but in any case, it quickly creates containers inside of Azure. So you really don't have to worry a whole lot about trying to wrangle a lot of infrastructure or doing any kind of stuff with that. You can pretty much just tell Azure what you need in terms of CPU and compute and memory, and then storage is all as a service as well. And then you can run your container. And when you're done running it, you can shut it down. And that's the great thing about container instances is you're only billed for the capacity that you use for the time that you use it. And so that might be for a minute, it might be an hour. You wouldn't want to run a container 24/7 in this particular setup because a 24/7 container in this context is going to cost more. So in that case, you will want to run something that is going to be more economical. And by economical, I mean something like Azure Kubernetes Services, or maybe Azure Container Apps, or even Azure Web Apps for Containers, which is based on Azure Web Services. So all of those are perfectly legitimate options for others, and we're going to be covering them in future videos. But in any case, hope you've enjoyed this. If you like this content, please consider subscribing to the channel. And as always, thanks for watching.
If you like this content, please consider subscribing to the channel by clicking on the subscribe button. You can also like this content by clicking on the thumbs up, or share this content with your friends, and also comment in the comment section down below. You can also find me online at www.blaze.net or on Twitter at @TheOneMule. And as always, thanks for watching.